This lesson is on solving radical equations. So there's going to be a series of examples in different scenarios for where the radicals are that we are going to go through. But first, there are two issues you have to be very careful of. Issue 1, you need to square entire sides and not individual terms. So, for an example, let's work with something that you know, and it's obvious. 3 plus 4 equals 7. Very true. Now, if you square individual terms, you get 9 plus 16 equals 49, which 25 equals 49. Not true. So, if we do it the right way, start with something that is true, and we square individual entire sides, well, this forces the order of operations. So 3 plus 4 is 7 squared, and on the other side we have 7 squared. We have 49 equals 49, and that makes us happy. So again, square sides, not terms. Okay. Now, issue 2 is to check all of your solutions, because sometimes when you square both sides, something that was originally false can be true because you end up changing signs. Here's what I mean. Here's something that is false. Now, if we go ahead and we square both sides, we end up getting 4 equals 4, which is true. And the reason why that happened is because we squared a negative number, which then ended up changing to something that is positive. So whenever you have that change of something that was negative to positive, that usually indicates that that solution is going to be extraneous. So it is very common in these problems to get extraneous solutions, meaning you solve for a solution where all the math is correct, but once when you plug that solution back in, it doesn't work into the original problem. So once again, check all your solutions. So first, we're going to work on solving a simple radical equation. So the first example here is the square root of x minus 2 equals 5. Our goal is to isolate the square root of x. So what do we need to do? Bring the 2 over. And now that the square root is isolated, in order to get rid of the square root, you want to square both sides. And we end up getting x, because the square root and the squared cancel, equals 49. So now we should check. Square root of 49 minus 2 equals 5. 7 minus 2 equals 5, and we get 5 equals 5. Good. So x equals 49 is our solution. Example 2. The cubed root of x plus 2 equals 0. Once again, we need to isolate the cubed root. So we subtract 2 from both sides, and we get the cubed root of x equals negative 2. Now, in order to get rid of the cubed root of x, our next step is to cube both sides. And we get x equals negative 8. Now, let's check it. Cubed root of negative 8 plus 2 equals 0. Well, the cubed root of negative 8 is negative 2 plus 2 gives us 0. So x equals negative 8 is our solution. So for the next problem, why don't you go ahead and copy it down, pause the video, work it out on your own, and then go ahead and give it, and then play to check your answer. So here is example 3. Negative square root of x minus 5 equals negative 6. Pause the video and give it a shot on your own. So here you want to add 5 to both sides. And then we still need to isolate the square root of x, but we have this negative in front, so we have to divide both sides with -1. That leaves us with square root of x equals 1, and then you square both sides, and we get x equals 1. Now mentally, you could do this work. Instead of writing all the work to check, you can mentally just plug in the 1 into here. So we have square root of 1 is 1, right? Times the negative is -1, minus 5 equals -6, which turns out to be true. So we did not get any extraneous solutions, and this concludes solving a simple radical equation. So now we're going to solve an equation with rational exponents. We will have 2 examples here. Example 1 will be 2x to the 1/2 power equals 18. So what we want to do is isolate x to the 1/2 power. So first we divide both sides with 2, and we get x to the 1/2 equals 9. Now what we want to do is raise both sides to the reciprocal of our rational exponent. So if the rational exponent is 1/2, we raise it to the reciprocal. Both sides will be raised to the 2nd power. So that, because when you raise the power to power, you multiply. So 1/2 times 2 is just 1. So we get x equals 81. Don't forget to check it. So now we do 2 times 81 to the 1/2 power equals 18. That means 2 times 9 gives us 18. So x equals 81 works. Example 2, 5x to the 3/4 equals 5/8. So the first thing here is you want to, again, isolate x to the 3/4, and that would be divided by 5. But we see on the other side we have a fraction, so instead of dividing by 5, let's multiply both sides with 1/5. And by doing that, these would cancel, so we have x to the 3/4 equals, the 5's here would cancel, 1/8. So our next step is to get the x by itself. So if the exponent is 3/4, that means we want to raise to the 4/3 power, which is its reciprocal. So now these cancel, and we just have x equals 1/8 to the 4/3. But we need to figure out what value this is. So that means 1 to the 4/3. So let's cross it out. 1 to the 4/3 and 8 to the 4/3. Well, 1 to the 4/3 just means 1. This means the cubed root of 8, which I could find out easily, and then to the 4th power, which is 1 over 2 to the 4th, and that is 1 over 16. So don't forget to go ahead and check it. You could do it mentally. You're plugging 1 over 16 into the x of the original problem. And when you do check it, it does work. Next will be solving an equation that has multiple terms in the radicand. So let's first start off with cubed root of 8x plus 3 minus 5 equals -2. So first, we want to isolate our cubed root of 8x plus 3. And that's easy. You just need to add 5 to both sides. So we have a cubed root of 8x plus 3 equals 3. Now we need to get rid of the cubed root so we could get into the x. So we need to cube both sides. So by cubing both sides, that cancels out the cubed root, and we have just 8x plus 3 equals 3 cubed is 27. So now you go ahead and solve the linear equation, and you get x equals 3. Now remember, you have to check it into the original equation. So cubed root of 8 times 3 plus 3 minus 5 should equal negative 2. Well, this becomes a cubed root of 24 plus 3, which is 27. Cube of 27 is 3 minus 5. Get negative 2 equals negative 2. So x equals 3 works. So for example 2, copy it down. 2x plus 1 is a radicand, well, square root, and then plus 4 equals 11. Pause the video and try on your own. Now here we need to subtract 4 on both sides. So we have the square root of 2x plus 1 equals 7. So now we square both sides. We have 2x plus 1 equals 49. Subtract 1 and divide by 2. So we have x equals 24. So now let's plug it in and check. I'm going to do it mentally. So 2 times 24 is 48 plus 1 gives me the square root of 49. So that equals 7, and then plus 4 gives me 11. So it does work, and x equals 24 is my final answer. So next, we're going to be solving an equation with 2 radicals in it. So what you want to do is have them on opposite sides. You want a radical equals a radical. That's what you want, to have radicals on opposite sides. So the first one will be a little bit easier. You have the cubed root of 2x plus 4 equals 2 times the cubed root of 3 minus x. So the radicals are already on opposite sides, which is what we want. We do have this 2 on the outside, and there's really nothing to do. I mean, if you divide both sides with 2, then you're going to have a fraction on the other side. So from here, what you want to do is get rid of the radical, and we just cube both sides. So when you cube both sides, and this is unique, I mean, the 3's here cancel, and we just have 2x plus 4, but on the right side, the 2 gets cubed, and so does the radical, so you end up having 8 times 3 minus x. And you have to distribute that, so you have 2x plus 4 equals 24 minus x. So let's bring the x over, so this becomes 3x, and they're going to bring the 4 over by subtracting 4, equals 20. Oh, I see what I did. I didn't distribute the 8. Okay. So how does that change things? I add 8x to both sides, and this becomes 10x. 10x equals 20. Therefore, divide both sides with 10, and you get x equals 2. Now, to check this, it can be a little tricky, and sometimes a calculator is required. Let's see what happens here. So we have the cubed root of 2 times 2 plus 4. So that's going to be the cubed root of 8. Oh, that's good. Equals 2 times the cubed root of 3 minus 2. So that becomes 2 times the cubed root of 1. The cubed root of 8 is 2, and 2 times 1 is 2, so it works out. X equals 2. Example 2. We're going to have the square root of 7x minus 8 minus the square root of 5x equals 0. Okay, this requires one extra step, where again we want a radical on each side of the equals. So let's bring the negative 5x over by adding it to both sides. So that gives us square root of 7x minus 8 equals the square root of 5x. So now that we have a radical on both sides, we want to square both sides. And we will have 7x minus 8 equals 5x. So let's bring this 7x over. So we have negative 8 equals negative 2x. Divide both sides with negative 2, and we get x equals 4. So now you can go ahead and check it. Square root of, let's see, this becomes the square root of 28 minus 8, which is 20, minus the square root of 5 times 4 is 20, and that would end up giving us 0, so x equals 4 is the correct answer. So here's our last type of problems. This is when we're solving an equation with two radicals and a constant, and these are the most difficult. So our first example will be square root of x minus 3 plus the square root of x equals 3. So we want the radicals on opposite sides. So I'm going to move the square root of x over to the right. So that gives us square root of x minus 3 equals 3 minus the square root of x. So now that they're on opposite sides, we square both sides. But here's where it gets tricky. The left side is x minus 3, but the right side, remember, this means 3 minus the square root of x times 3 minus the square root of x. So you have to distribute and combine like terms. And when you do that, you get 9 minus 6 square root of x plus x. Take your time, pause the video to make sure you understand how we got that. So now we have a new concern. We have a square root, another one still, but at least there's only one. So whenever you have one square root, you isolate that one square root. So we are going to subtract x from both sides, which works out nice, they cancel. I'm going to subtract 9, so that becomes negative 12 equals negative 6 square root of x. And then I'm going to divide both sides with negative 6. And I have 2 equals the square root of x. So now the x, square root of x is by itself. You go ahead again and you square both sides. And we end up getting 4 equals x. So now if we go ahead and we check, let's make some room. Remember, you want to check in the original problem. So we have 4 minus 3 plus square root of 4 equals 3. So it's the square root of 1 plus 2 equals 3. So that's 1 plus 2 equals 3. 3 equals 3. Look at that. Once again, our answer works. So to recap, bring a radical on both sides of the equation and then square both sides. And if you get a radical again, you go ahead and you isolate that radical, square both sides, and then take it from there. So here's our last problem. Very similar to before, the one we just had, with the small tweak. Square root of x minus 3, but now we're going to have minus square root of x equals 3. Alright, so same thing. You want to bring the radical on opposite sides. So we'll have square root of x minus 3 equals 3 plus square root of x. And now you square both sides. Be careful when you do this. And you get x minus 3 equals 9 plus 6 square root of x plus x. Alright, so now we need to isolate the square root of x. So the x's cancel out. I bring the 9 over, that's negative 12. equals 6 radical x, divide both sides with 6, and I have negative 2 equals the square root of x. So now you square both sides and you get 4 equals x. Alright, so now let's check. You have the square root of 4 minus 3 minus the square root of 4 equals 3. So we have the square root of 1 minus 2 equals 3. 1 minus 2 equals 3, and you get negative 1 equals 3. Well, our last example is something that is false. So this x equals 4 is not our answer. That is extraneous. So therefore, what is our answer? It's no solution. The red flag where you knew that this was going to be no solution was this step here. When we had square root of x equals negative 2, and when we squared that negative 2, it turned something that was negative into positive. So that's something to look out for to know if there's a possibility of no solution.